One of the things that you may have noticed in Kotlin is this whole inline business. So what is this inline business about? So inlining is primarily an optimization technique. So the idea is that you have, rather than the compiler just making a function call like go to that bit of code there, execute whatever it is, and return back to where you came from. Inlining is the idea that you basically put that right there and then in the code that is calling it after the necessary transformation, just to make sure that it all works correctly. It's just a bit of renaming of variables and stuff like that. Of course, the compiler doesn't actually, or the execution doesn't actually use names anyway. So when we have this, we have very short functions. This can be a very effective strategy. Sometimes calling a function and the function call overhead is more code than it actually needs to be. For example, if you have a function that that is just a trivial getter or trivial setter, the code there is really boring. It's just read this field or set this field without any meaning. You can just replace a function call with that, and it actually is both each one instruction. However, this is not something you normally need to worry about because the compiler does this all for you, or in a direct-to-machine code language like C or C++. In the Java world, the JVM or the Android runtime takes care of that. So they optimize, you don't need to worry, but trust that trivial getters and setters are not any more expensive than directly accessing the field. So having those does not actually make your code any slower. So in the Java world, the compiler does not do it because the JVM is said to be able to do this better and also to have a better understanding of what the correct policy is to use for this. But Kotlin adds some features where basically the JVM kind of starts to fall down and can't do what needs to be done. So one particular one is that in Kotlin you can actually have a non-local return from a Lambda body. So in the Lambda body you can say return, and that doesn't return from the Lambda, it returns from the function in which the Lambda is declared. So you have three parts. You kind of have the function block where you write the code. Then you have the function that takes the Lambda, and then you have the Lambda itself. And if you type a return inside that Lambda, it will return to the outer function block in which it was declared. Basically, as if you just have a regular code block. Just happens to use some Lambda function. So basically, like it's a control structure. And this is a very powerful way of doing this, but the only way this works correctly is if you use inline functions. Otherwise, a return will just return from the Lambda and then go into the calling function, etc. So there's when you write these functions, that function has these control blocks you need to take care of, because non-local returns bypass that as well. There's another function called reified type parameters, where you basically, if you want to record the past in type generically, you can use reified type parameters so that you do not have to pass that explicitly. It will just take the type parameter. Obviously, the JVM does not support doing that, but an inline function can say, okay, this is the type I'm being called with. Still at compile time, obviously. Now you can access this type and store it as a class file or whatever you want to do with it. It can be really convenient, and you see it in some libraries that use this. So there are some examples of these that hopefully make it a little bit clearer. So the first one is the Kotlin run function. That's actually two functions. So Kotlin run function has a variant with a receiver and a variant without a receiver. So this particular variant, and let me see if I can make this so you should be able to see my mouse very well now. So my mouse should be here, yes, on a different screen. So receiver is basically the idea that you can have a function that takes the disk pointer. So the run function basically does takes a lambda parameter and then runs that parameter with the original receiver as a receiver. So in this case we print this +5 or print +6. We have a quick look because I think I've gotten a little bit my code samples got a little bit messed up. Okay, yes, so there is I have a code sample for how this actually is implemented, but it seems to have disappeared.
Okay, as said, this wasn't recorded properly, but so this is what run without the receiver looks like. So there's no object that we capture. That's the only difference. And then 2 slides in, we see the implementation of both run methods. We see the contract and we see that it just returns the result of calling block. That's all. And it doesn't do anything. So this version has the disk receiver taken from the object, and this one has no object and there's no disk receiver.
So another thing here is that so in this function, so we can the disk parameter, this name refers to the receiver. In this case, this is 2. Yes, so as the comment says, this kind of code is not pretty, and this is not the kind of place where you would actually use run, but it shows how it works. What you would use this for is if you have an object, something that is an object, or if you have a number of functions that you want to call on an object, but you don't want to write object dot do this, object dot do that, object dot do such. And yes, so Kotlin has operator overloading, so plus is exactly the same as the plus, but because we don't have to have a receiver, because in this case this is implicit, you have to have it with the operator but not with the method name. This is the same as this +6, but as I say, it is quite confusing to do that. So there we are. So and then the return value of the of a run block is whatever is the value of the last statement, the last element in the block. And if that's not a regular block, that would be unit or nothing if it's a return statement or a throw statement. There is another function that is very common here, which is called apply. And to apply, you have seen that in the some of the sample code in the exercises where I did it. So the idea of apply is that you can basically have an object and then do something with it and then return the original object. So if you want to do updates on an object, you can use the apply function. So in this case, what we would be doing So we take our paint object, we create a paint object, and then we want to configure it. So we call the apply method. So in this case, we set some style and we set some color. By the way, I haven't checked that this is the exact correct Android syntax, but it should be okay. So the idea is that we can modify this. So how is this implemented? So one of the things you can do, which is always very useful, is to use actually stand on the method and press, if you're not on a Mac, Control B. On a Mac, you have to find out. It's called go to declaration. So we can have a look at that later as well when we go into Android Studio. So in this case, we set this. So what does this look like? So this is the sort of the implementation. There were some annotations that I left out. So it is an inline function that has a receiver of any type T, and then it has as parameter a block, and the type of this block parameter is a function that takes a T as a receiver, has no further parameters, and then returns a unit. And the entire function returns the type, something of the type T. Or it actually returns exactly what it gets as an input. One funny thing that's added here is this contract bit. So this contract bit is just where the code communicates to the compiler. It doesn't actually result into actual code. I'll go back to the contract in a little bit. So what we actually look at is this, basically the actual functionality is this block where we actually call the function. As we don't need to explicitly do this.block because this is always implicit, and the object that we call it on is already implicit as it is a receiver. And we have the block, and then we return the original value in this return statement. So that is all that apply does. So apply is actually a very simple function, but it is one that is very, very powerful. And there's many variations of this. Run does basically the same thing, but it returns the implementation of block, or the return value of block. So it has another generic parameter. I think it's called R, and it doesn't return unit, but it returns R. So it has a function that returns R, and then the return value of run would be R as well. You can see some variations of this, and you can look at this standard thing anyway. So this contract business. So contracts. So basically, the idea of contracts is that there are some bits that you want Kotlin to do well and to use your lambdas as controls, or your lambda taking functions as control structures, but the compiler doesn't really have visibility inside this. So if you say you have a run block or an apply block, that will always be run exactly once. But the compiler doesn't know that. So if you initialize a value inside such an inline, inside a block, there's a little bit inline going on, but the compiler doesn't know that the value has actually been set there. The contracts are basically there to help that work correctly. They are also there to help that a function such as string dot is null or empty, if that returns false, the compiler then knows that the string value is never going to be null. Without contracts, it doesn't know as a compiler level that the value wasn't null. It just has a true or false value, but we don't know what it means. So contracts allow the compiler to reason what happens inside such an inline function. But of course, very important there is that you do not lie to the compiler. If you do that, then all kind of funny things will happen. So yeah, don't go there. That's not going to be very helpful. then we have the with function. The with function is slightly different from apply. It actually does not take a receiver, it takes a parameter. And otherwise it runs very much like run. So the equivalent in run would be textpaint.run and then the same block as you have. So in this case, so we create a text paint. In this case, so you could take the text paint as a parameter directly for the width. In that case, that is in this case not valid because the paint just disappears and there's no point in doing this. So this width block actually has a return value which is unit because an assignment does not actually have a value in Kotlin. So color equals color.rgb does not have any value. So the value of the width statement is unit. And you can tell Android Studio to actually display these values. So that is how this works with width. So how is this implemented? Basically, width again has a contract, but rather than returning the passed in object, it returns the result of calling the block. So you can see that, for example, so here we have this R return value. So again, it's very similar to how run would work, except run takes the t.run rather than the receiver. And yeah, so that's how this works. And all these functions are very similar. They are all basically one or two statement functions, but they are extremely powerful. So a common one is let. So let takes the receiver and makes it and allows you to basically give it a name and then do things with it, and then returns the result of the last expression. So if you have an object, so we have in this case created a function that just creates 4 random integers. So this int array is actually a built-in function. This is kind of something you cannot really do yourself because the way how it works. Because arrays in Kotlin are they have to somehow work with the way that Java arrays work. So there's some compiler hackery going on there. But the concept is still very possible, and I've used the same one in the matrix class, for example. So in this case, what we want to do is, so what it does, it just gets 4 random integers using the random thing. So basically, the int array has an initializer function so that you always have a value in this. So when we have then we can use this to get this myString value. So yes, by the way, yes, so these t's are always generic parameters. So to allow you to accept any data type. That's 100% correct. Thank you for that. So we can use this to so in this case I just use the result of that getInst function. I don't really want that, except I want to do some transformation, so we just make it here. In this case I use the name it for it still, because whatever, and then I join those elements to a string, and I set a prefix and a postfix. What I do here is, because I actually have it as a variable name, I can then also use it to get the name of its class and use it that way. So that's an additional thing you can do with with this. So otherwise, it would be the same as if you just call join to string directly, because that's kind of what it ends up at. So this is, okay, I need to have some temporary, I need to have this thing, I need to call a function on it, but in the meantime I need to do something with that object as well. That is what let can do. In a way, run can do this as well, but run does pass it as a receiver. Very often using it as a receiver becomes very hard to understand what is going on. But even let can get complex. So in many cases, you are actually very much better off by just actually making a local variable, storing the stuff in the local variable, and then getting on with using that local variable. Another caveat there is that the debugging experience for these control structures is not entirely where we'd like it to. So how does let work? So again, it's very similar. So it just returns the block, but in this case, we pass this object as a parameter rather than as a receiver. So it just converts how you're calling it in a way. So it's a really simple, tiny building block. Then we have the also function. The also function is basically, it's the parameter version of apply. So where apply takes the object as a receiver, also takes it as a parameter. So it's basically, rather than having it as a or as a receiver, will be a parameter. So it just, yeah, it calls a block with this as a parameter and then returns this. Whereas the apply one took the this dot block basically. A slightly different one is use. One thing you may notice with Java, there's this try with resources construct where you can use resources and then automatically have them closed. Kotlin does not have that as a language level. However, Kotlin has the use function. You could even write your own use function, and this use function does basically the same thing. So what does this look like? So we can have here, for example, a file reader that reads a file. So we create that. Then we have the use function. The use function takes this and automatically closes this object. So this object is passed into use, and the return value of use is whatever is the return of this statement. And lines 5 to 6 all have this statement in there. So what do we do with the reader we have now? So we need to give it a name, obviously. The use does not have a receiver function. You could then wrap it up into a run or something, but it just gets confusing. Named parameter is much clearer in this case. So we have a string writer that we're then basically also want to do something with. A string writer, we could use the use with string writer, but string writers are just strings, they don't need to be closed. So with the writer, then we say actually reader, transfer your content to this writer. That's a function built into reader that basically says whatever's in there, put it into this writer. And the string writer then has a toString function, which basically gets you the string out of this writer. The string writer is just a writer that writes to a string builder. And when you get to string, you get the content of that. And then we can print the content. So the result of this toString will be the result of this block, and then will also be the result, so the value of content. So we can actually read the content of a file with this particular bit of code. There are better ways of doing this, but this is an example of how you would use. So that is how this works. So how does it implement it? So this is implemented in two parts. So there's this inline function on the top, which is the use block, and this particular block. So what we do here is we have a try catch finally block. We also store an exception that's has been thrown. So it's a bit tricky. So the standard thing is just return the block and this, and then finally close the closable, the object that we're trying to automatically close. We need to use finally here because this inline function could have a non-local return. Non-local return does actually so the non-local return does crash the so does not return the a non-local return basically would break this inline function, but it does not cannot escape a try block. So in the final, we know that the finally is always called whatever way we get out of this inner block, and that's what we need to be able to do to automatically close it at the end. So if you just say try and then call finally, that doesn't work. Of course, also with the exceptions doesn't work. So then, so what we do, what happens then is in the catch block, there is a throwable that has been thrown there. Oh yes, by the way, yes, I do record the lecture and save it. Don't worry about that. So, so the exception is stored so that it can be passed then into the close finally block. We look at what does close finally do. This is actually an internal function, so it's only accessible within the module. So in this case, it would be this Kotlin standard library. So while we can see this code, because the code is provided, you cannot actually call this yourself, unfortunately. So this one is a function that says, okay, that takes the closable as a receiver, and then basically say, okay, if it's a null value, don't do anything. If we don't have any exception, we close this and just do whatever we need to. But if there is an exception, we try to just call close, but as we are in an exceptional situation, it might be that close throws an exception. In that case, we want to still record that exception somehow, but now we have two exceptions that we somehow need to choose. So Java has this idea of you can actually add suppressed exceptions to an original. So the original one is the cause, and what we do is we add this suppressed close exception to it so that we don't forget about closing the thing also field. And this is exactly what the Java compiler does in the try with resources. But in Kotlin, this is done at library level, and you could write this code yourself. And
published API is based on the idea that sometimes, so by default, the JVM has the, let me have a quick look, I hear myself, this is annoying. So what happens sometimes is that when we have an inline function, or say the JVM basically enforces accessibility. That means that you cannot call a function at runtime, even though you could possibly do this at compile time. So normally in a normal language, it's only the compiler that enforces visibility. In Java, that's not the case. So for an inline function to be able to call its methods, we need to be able to actually say, here is the method that we're going to call. So it needs to be able to call have that visibility. Same time, sometimes you have functions that you do not want to be called directly, only through an inline function. There are helper functions, like in this particular case with the close finally one. So what you can do in Kotlin then is use the public API annotation. This means that the compiler will enforce this visibility when you're calling it, but not for inline functions. So it is visible at public, so users could technically get at it if they really wanted to, but the Kotlin compiler will try to stop you from doing so. So it becomes technically also part of your API, because if you publish a library, that could break.